Hey, this talk is really about how the cloud is an opportunity and how a hybrid cloud is not really an extension of your data center into the cloud. A hybrid cloud is basically keeping your existing systems running as you do in your existing environment and then leveraging cloud resources and cloud capabilities to improve your process, to increase automation, and to shorten your release cycles. It's also a way to make sure that your various environments, various applications run the way you expect and that they are not manually configured, that these things are not required to run your operation and to deliver new business functionality. And the idea here is, this quote didn't come from the cloud area, but basically by continuously doing a process and adjusting, you become even better at it, and it increases the level of excellence in your organization and your ability to deliver. So, the point really with cloud is not that it's a remote data center, and I think this is where a lot of people talk about whether it's a new shiny object or something else. The idea is that life in your cloud environment should actually be different than it is in your current data center. When you move to the cloud or you start building out applications in the cloud, and the reason I kind of phrase it this way is I have seen a couple government projects where their idea of going to the cloud was basically a complete lift and shift even of some of their hardware into their cloud vendor, which really meant they were just doing a hosted data center. The idea with why the cloud should be different is it's an opportunity to bake into your process policies and practices, to make them core to what you do rather than being some kind of extra thing that one weird team does, right? The cloud vendors provide infrastructure and capabilities that you don't have to customize, that you don't have to think through on your own. You just layer your pieces on top of it. One of the things about the cloud is, so the cloud vendors in their own environments are so large that they can't hire enough people to maintain their environment and deliver applications and their services. They have to fully automate, and their ability or their need to automate their infrastructure means that you can automate your infrastructure, your deployments, your security. It is full automation is possible, really. They're really, as you move through, your dev and your QA and your production environments, you may use manual processes for the first go around in dev, but after you've shaken it out, everything is automated the whole way up. One of the interesting things about the cloud is because infrastructure and routers and networking and load balancers, they all are recipe driven, they all are script driven. You can continually tear down infrastructure, components of your infrastructure, and rebuild them and verify that you know how they're built and verify they're on the latest patches. Make sure that all the environments are the same, because part of your deployment, you may have like a mini and a main deployment or one kind of deployment. All those pieces come with it. Another area where the cloud is different is that you have dynamic and on-demand capacity available to you, right? So what that means is you can add capability either a priori, knowing that you need it, or you can add it on the fly, although you have to be cautious how you do that. You also have the ability to adjust your capacity based on price. Or one of the places I worked at, they have a lot of nighttime jobs. They have a lot of big data jobs. They actually spin up machines and run those based on pricing. So they'll either go into a bid market for machines so they can get their thousands of machines they need, or they'll go and do other kinds of reserve. So, many of the vendors have a variety of pricing. When you're in the on-prem or your internally hosted environment, you kind of need to manage your processes around the number of machines you have or the capability. Another thing in these environments, because they're multi-tenant or they're set up with accounts and kind of different organizational units than typical internal, you can get easy application or team isolation. That tends to be something that's really hard to do, and it's kind of manual to make all that happen. You can get some of that for free. I've seen some people where they want to do hosted environments, they want to sell their software. They actually have the ability to easily spin up a new mini data center, a cloud account or subscription, and they can deploy those apps in it, and they get isolation, and then they can work and partner with their customer to see who owns which piece of that. When it's done or the deal goes away, they basically pull the plug on that subscription and that stuff goes away. Another interesting thing where the cloud should be different is resiliency is part of the design. Typically you build something, software developers, they build something and then they kind of work through how it's going to work, that type of thing. But really, you don't spend a lot of time on making sure I don't mean not making sure it stays up, but that kind of work. In the cloud, machines will go away at random. They'll be provisioned. Their IP addresses will change. they'll move from one data center to another as load, or if there's a problem, they'll auto-migrate. I mean, there's a lot of things that can happen in the cloud environment, and so those have to be taken into account when you build your application. So life in the cloud should be different. It shouldn't just be another data center. If it is, you're either not getting the advantage of it, or maybe some people in the organization don't understand what the value proposition for that is, right? So hybrid, and this is kind of same idea, right? So we're just going to cover a couple of these. So you get the ability when you have the cloud part of your hybrid cloud. So you'll see a lot of places, they'll stay with their current security model, and then when the cloud side of it will be completely rebuilt. So in the, a lot of places I've been or seen where maybe all the network traffic is in the clear, and they do very minimal authentication or authorization because it's a trusted shell. When people go to the cloud, they don't trust the cloud, so they actually start building real security models into their applications and into their infrastructure. So you'll see people encrypt at rest, they'll encrypt in transit, they'll encrypt in the data stores or on the disk. They tend to do more application authentication and authorization because there's a natural paranoia about being not in your local data center that you probably should have had on-prem to begin with. And so people will take that into account. There's a lot more work done for credential management and for credential lifetime in the cloud by the different cloud vendors. The Microsoft guys have done that on their side. I've only have experience with Azure and AWS, and both of them do that. So the hybrid cloud also is not an offsite data center from the sense of how you do deployments and configuration. As I said before, one of the big things in the cloud, if you really want to, I think take advantage of it, and you want kind of the major benefits of it, is heavy automation. I mean, there's a big push for continuous development, continuous integration on the development side, continuous deployment, right, and continuous delivery. And those only really work if you're automated. That typically was pretty hard. You had to buy kind of different vendors' tools and hook all that together. Your cloud vendor will have all of that available. So you'll see people that automate build and test. They'll automate standing up routers and load balancers, subnets. They'll stand up new application clusters or different tiers in an application. All of that will be automated. Monitoring, there's built-in monitoring in a lot of cases. Worked in a couple environments where we used Splunk or AppDynamics or some of the other monitoring tools, and we will just puppet or somehow recipe those into our automation. So we'll use the cloud vendors tooling, and then we'll route that into our own monitoring. And we guarantee in these environments that everybody has to be on board with the monitoring and logging and those kind of pieces. And then data handling, and then price and performance selection. You can actually automate your pricing if you decide you need a certain level of service. You can pay to get that, or if you're more budget driven, you can also work around when and what type of machines you have. You might let your stuff run a little slower part of the time, or revalue your machines based on, we have an annual submission cycle or a quarterly accounting process, and so maybe we need to bump those machines up during a part of the year and then go back down. You used to see kind of this on the mainframe. Like when people were at peak, sometimes they would buy an extra engine on their mainframe. You really couldn't do that in kind of the server environments, but you can do that in the cloud. So probably one of the biggest things that's interesting on the cloud, this automation piece is huge, is this notion of service catalogs, that you can do zero infrastructure provisioning of certain types of resources. So pretty much all the cloud providers have SQL and NoSQL data stores. They'll have their own internal SQL database. They'll have an object store. They'll have some kind of blob or table or bucket storage. Many of them will actually provide caching solutions. So if you need a caching cluster for performance, you don't have to configure that, and you don't have to stand it up and size it and all of that. You can actually work through their automation to bring that online. They'll have indexing or search. If you're in AWS, you can have Elasticsearch or Cloud Search. I was talking before about caching. You could do Redis over on the Azure side. And then one that they've all definitely brought up, so if you don't want to stand up your own messaging, they all have different messaging solutions. Now, these tend to be very cloud, not e-commerce, but kind of generic. So if you need some special net messaging solution, you might have to stand that up. But if you're doing most of the basic messaging, you should be able to handle routing and queuing and that type of thing. You can always encrypt your payloads if you're worried about security. Some of them have encryption with your keys at rest, so that when messages are parked, They're parked at rest, and then you do key management so that the vendor can't see it. So there's a lot of interesting things in the data service catalog. On the non-data service catalog side, and again, if you're thinking of hybrid cloud as a data center, you can't make use of any of this. If you're thinking of hybrid cloud as a go-forward architecture where the on-prem is kind of legacy or for specialty, and the cloud is where you really want to be, then you can make use of a lot of these, like these non-data service catalogs, right? You have all the provisioning and sizing we talked about. There's usually monitoring, performance, there's outage monitoring, there's notifications. In AWS, they can post errors to queues, and you can hook the queues up to your messaging. In Azure, you can use their HD Insight and some of their other management tools so that you don't have to stand them up yourselves. The non-service catalogs include compute. If you decide you really want to manage your own infrastructure, but you want to use their servers, you can use their images. That is kind of similar for some of the cloud if you're doing Hadoop or some of the other big data pieces. A lot of times they'll have pre-configured computation that you can allocate out. It won't really be like a service, but you won't have to stand them all up and patch them and do all that stuff yourself. The catalogs also support scaling, so if you want to set the size or your compute pools, and when nodes go down or when you have certain kinds of load, they'll automatically bring up additional nodes or tear them back down. And the other non-service catalog, typically firewalls and network, it's still an art in a lot of ways, but the tooling is there for the artists so they can be power artists now. And then you can use automation to provide all that. And we know that that piece works because they have so many customers in most cases that there's plenty of people using the same tooling. The other thing a lot of people do is they'll have other platforms that let you deploy custom applications with zero infrastructure provisioning of your own. Basically, the platform comes with its own provisioning pool, and the vendor takes care of it, and you just drop your code into it. That means you don't have to be doing the custom configurations as much on the machines. You don't have to have people logging into the machines. I mean, typically, these are the two most dangerous things in your enterprise, right? They tend to do things on the keyboard, and bad stuff happens. So the idea here basically is these data and non-data service catalogs really give you a bunch of freedom to pick up and work on the shoulders of others. And you leverage all the infrastructure or the capabilities that these people have built that are being tested by other companies. Another thing that's really interesting in the cloud, on the cloud side, so some people like this and some people don't, but kind of in the agile vein of it being, transparency, cloud gives you a lot of accountability tracing. So typically in a data center, I've seen data centers where they really get squirrely on the hardware or whatever, and then they jam a whole bunch of apps on a given machine, and you don't really know which group is consuming most of those machines. In the cloud, you have the ability to size machines the way you want based on the cost and performance you want, but everybody can be on their own hardware. Everybody can be on their own monitoring plugins. So costs are explicit. You know how much every team is spending, or you know what an app costs you. Then you can really decide what the value proposition. I'm not necessarily talking about chargebacks, but this kind of notion of how big is that app, how complicated it is, how much work's going through it, what is it actually costing us? Does that make sense? Should we make changes to those applications to make them perform better? So resource consumers are exposed, right? And one of these accountability things is teams can control their own deployment models and their own costs. So, hey, we always wish we had a second dev server and nobody ever let us do it because the data center was full or the team didn't think we needed it. Well, if we need it now, we can stand it up. But if we're automated, we could actually stand up that extra dev environment for a week during some kind of testing or some kind of development, and then we could tear it down and bring it back when we need it. So they get to really control their own cost model, and they get to control their own capabilities. Another thing with the cloud accountability is the consoles. You typically don't have a lot of custom consoles, and so you'll use, you hope, the instrumentation of the cloud vendor to see what's happening, and you can see how that compares to other teams and kind of what their cost models look like. So the cloud is pretty different, right? You get these kind of, all these capabilities. The key, I think, really comes down to deciding it's worth it to you, deciding that you want to get out of the business of having to have more people or having, what we used to joke that there's a one deep organization where you have that one specialist. So you still need specialists. You still need people that are experts. But the idea is to leverage them through automation, right? Not leverage them through ticket or through phone call, that type of thing. So what are the main risks of a cloud deployment? A lot of people think it feels like a shiny object, so they don't really do the whole thing. They just kind of decide it was the fancy thing, and like some VP somewhere thought it was important, so they did it. So that's bad. If you're doing it because it's a shiny object or a resume item, you're probably doing the wrong thing. You really need to get a hold of encryption and cert management and encryption keys. In the data centers, a lot of times people don't do a lot of security, really. Basically barely passwords and usernames a lot of times. So this is something that'll really, you got to manage, right? And a lot of times it comes down to who owns access to those. If you're doing a joint venture with somebody in another company and you spin up a cloud data center for them, who owns which keys, those type of things. The edges have to be protected, and this is the one that always gets people. They always really get paranoid about it. You need to watch where your bridges are to your on-prem, and which parts you made public and which parts you made public to or exposed to your partners, right? It's really no different than the on-prem. It just feels that way. But you need to watch, because some of the cloud vendor services are actually public. You actually go out of your network and back in through the public side of the cloud to get to it. So sometimes you'll decide to use that service because you don't want to use a public service. Even though you did access controls and security around it, you may still not want to use a service that's publicly exposed. Your own services, you have to be cautious of the same thing, right? Because it's really not your data center, so you have to pay attention and automate the application of security rules to those things. One of the other things about continuous delivery and continuous deployment is really this notion that more of your staff's going to have to be multifunctional. I've been in 2 cloud engagements so far, and in both cases the developers had to learn more about infrastructure than they ever had to know before. And so that can be difficult. At the same time, it increases their value and understanding, and they tend to build slightly better applications, or maybe more than slightly, because they understand how it goes together. So there's some risk there that you have the people that can do that. The other thing is you probably have this automation fight. So a lot of people were used to, they claim they automate, but you really look at it, they've gone in and typed something. The last 2 places I worked on cloud, the notion was that nobody should be allowed to log in production. This actually turned out to be quite scary. We got all the deployment and all the provisioning, but when something went bad, the question was, did we have enough instrumentation and tooling to really understand what was going on? So some people will not even believe it's possible, and other people will feel threatened. But we know this can be done because the cloud vendors themselves do it. Netflix and other companies have been used as a good example. There's plenty of places where they have too many servers to touch them by hand. If they can do it, you can do it, but it is one of the risks involved in the process. So I guess it really comes down to is more is possible in the cloud, right? There's a lot of capabilities there beyond being a data center, and it really comes down to changing the way people think, which of course is the hardest part of any change, right? Technical change is easy, tribal change is hard. So what I would say in the end, wrap up, if you have a cloud that smells like a data center, then you've lost the opportunity to change the way you operate and to leverage automation to increase the capabilities of your team and the amount of deployments and the amount of code, the amount of business functionality that they can give for the same dollar. So I guess that's it. I was trying to keep this to 15 minutes, but it's actually 20. So there's no time for questions. Give me some feedback on it, and we'll see what else we can come up with.